So the assignable variation and the common variation is what we discuss, and we're going to go to the next slide, which is going to be how do you calculate the variations. This is something that you have done already. You know what is a mean and you know what is a standard deviation. You have done this before. And sigma is often referred as the standard deviation, and it measures how much observations deviate from the mean. So if I have, this is the mean of like a diameter of the pen that I have. It might take the first observation. So I'm going to take the pen, okay, and then I'm going to put a caliper here and look at the diameter. I get this point here. Then again, I go down and measure this, and I get it here. Then I get one maybe here. So this variation or the variability is the standard deviation. Basically, I really want it to be within these points. I want all my data here rather than here like that, because I want a tight specifications. The closer these data are to the mean, then it is better. That is what standard deviation tells you. Okay. Process capability, on the other hand, tells you how this particular process, how good it is, whether it is within the specification limits, within the control limits, and all that good stuff. How consistently you can produce a good product without much problems with quality. That gives you the process capability. So let's take an example. So here I have, this is my lower specification limit. This is my upper specification limit. This is my lower control limit. This is my upper control limit. Okay. Now what is happening here is my control limit is over the specification limit. So there is a problem with it. It has to be within. If it is like this, then that is great. It has to be within the control limit. The specification limit and the control limit should be such a way that your controls should be within the specification. Okay, then you have a much better process. So let's take a look at it. How do? You have an original process, which is this, and if you squish this and become an improved process. So now you're having better controls of the process. Okay, we haven't changed the specification, but it's just squishing such that you're going to have a better control. So control limits are the main things in this whole process capability. So what I'm going to do is to give you this example later on, but we're going to use this equation. If x bar is the mean, and sigma is the standard deviation, I'm going to calculate x bar minus the low specification limit and the upper specification limit and the x bar, and divide each one of them by 3 sigma. You get two different numbers. And the minimum of those two different numbers is the process capability index, CPK. CPK larger than 1 indicates process is capable. Otherwise, it is not capable. Okay, so CPK should be greater than 1. Okay, so we'll be doing some problems with that later on. We're also going to look at control procedures. Control procedures have got variables. These are characteristics that are measurable. These are measurables. These are measured variables. Like for instance, if this pen, the thickness or the diameter is a variable. Attributes or the quality characteristics. I want the diameter of this pen to be 0.25 inches, and not more than that or less than that. And that is what I want to calculate and make sure to determine the quality. That's what I'm looking for. Okay, that is your attributes and things like. Let's take a look at the process control examples. These are the different charts. Okay, these are different charts. And in every chart, for instance, this chart is a problem. This chart is great. This chart is a problem because some of these points are outside the control limits. We want to make sure that the points, the data that you're collecting is within these limits. And if you're within these limits, then your process is good. Okay, and that's the whole idea. We're going to be doing only the X chart and R charts. We're not going to do P or C from the book. The book has all four, but we're going to do only X chart and R chart. And I'm going to give you in the exam only X chart and R chart. So let's do the X chart and R chart. I don't want to do anything which is not covered in the exam. That's the reason I would like to do this. P's and C's can be done, and is just basically putting something in the equations. You can do that. But same thing with X and R. You have to just know one equation and you can get the data and put in the numbers, and then you get the X chart and R chart. Okay? So to do the X chart and R chart, we need the size of samples. We need to know what are the variables. We need to know the number of samples, the frequency of the samples, and the control limits. Okay? So let's do some things with X chart and R chart. The first, I'm going to look at or define the upper control limit and the lower control limit. The upper control limit is typically the average plus a z-score times the standard deviation. Whereas the lower control limit is the average minus the z-score times the standard deviation. If I give you the mean, the z-score, and the standard deviation, you can calculate the UCL and LCL. Or if I give you some data, you can calculate the X bar and the average and the standard deviation, and you can look up the z-score like you did in your statistics class. So X chart basically takes the samples, and we're going to use those sample data and construct the X chart. Same thing with the R chart. We're going to construct the R chart. R basically is a range. So if I have a data, the highest data and the lowest data, the highest number and the lowest number, if I take the difference between these, that gives me the range. Okay? So if I have something like this, this is exhibit 1013. 1013 gives you the numbers. It gives you A2. It gives you D3 and then D4. Okay? D4 is the upper control limit. D3 is the lower control limit. These are the factors of lower control limit and the upper control limit. I'm going to use these equations to get the X bar chart or the R chart. Okay? So the way to look at is this. Suppose I have 5 as samples, 5 samples. Then I'm going to look straight here. I'm going to pick up this number for my A2, this number for my D3, and this number for my D4. Basically, that's what I'm planning to do. And use those A2, D4, and D3, find the range, find the average, and you got it. So let's do some problems with this. And you can always make a chart. You take after you calculate the upper control limit and the lower control limit, You put the upper control limit as a line, lower control limit as a line, the X bar as the line, and the data. Show the data. Same thing with R. The upper control limit, the lower control limit, and then the R bar mean, which is R mean, and then the data. That's what you need to show. Okay, let's do some problems.